Students, today now we are going to start our second chapter of geometry, Pythagoras theorem. So we are going to Pythagoras theorem. First we will study some terms related to right angle triangle, because Pythagoras theorem is related to right angle triangle. So first we will study some terms related to right angle triangle. Suppose this triangle A B C is right angle triangle. So in this triangle, angle ABC is equal to 90 degree. The side opposite to 90 degree is hypotenuse. Therefore here AC is hypotenuse. Hypotenuse of right angle triangle. That means the side opposite to right angle is hypotenuse. And hypotenuse is the larger side of right angle triangle, and remaining two sides AB and BC, these two sides make right angle. So one side is called base, another is called height, or these two sides are called the sides making right angle. So now we will study the Pythagoras theorem. Pythagoras theorem. The statement of theorem is, in a right angled triangle, the sphere of the hypotenuse is equal to the sum of the spheres of remaining two sides. Now see here in the figure, triangle PQR is a right angled triangle, and angle Q is of 90 degree. In triangle PQR, measure of angle PQR is equal to 90 degree. That means this is a right angle triangle, and the side opposite to right angle is hypotenuse. That means here PR is the hypotenuse. So according to this theorem, the square of hypotenuse, that means square of PR, so length of PR square is equal to the sum of the squares of the remaining two sides. So remaining two sides are PQ and QR. That means length of PQ square plus length of QR square. Hypotenuse square is equal to sum of the squares of remaining two sides. That means PR square is equal to PQ square plus QR square. So we can write this as PR square is equal to PQ square plus QR square. So this is the formula of Pythagoras theorem. Now suppose if length of PQ is Q, length of PR is Q, length of PQ is R, length of RQ is P. So putting these values, we can write this formula as Q square is equal to R square plus P square. So this is called the Pythagoras theorem. Now we will see Pythagorean triplet. So Pythagorean triplet means in a triplet of natural numbers, if the square of the largest number is equal to the sum of the squares of the remaining two numbers, then the triplet is called Pythagorean triplet. Now we will have one example here. For example, this is one triplet of natural number 3, 4 and 5. So here in this triplet the larger number is 5. So 5 square is equal to 25. The square of the larger number. Now we will find the sum of the squares of remaining two numbers. 3 and 4 are remaining two numbers. 3 square plus 4 square. 3 square is equal to 9 plus 4 square is equal to 16. That is equal to 9 plus 16 we get 25. That means here in this triplet or in this group of three numbers, the square of larger number is equal to the sum of the squares of remaining two numbers. That means here 5 square is equal to 3 square plus 4 square. Therefore, three numbers are called Pythagorean triplet. Pythagorean triplet. Now, one more example we will have here 11, 60, 61. In this triplet, the larger number is 61. Okay, so here square of 61 is equal to 61 multiplied by 61, we get 3721. Now, the sum of the squares of remaining two numbers. This is a larger number, the 61, the square of 61 is 3721. Now, 11 and 60 are remaining two numbers. So we will take the sum of the squares of two numbers. That means 11 square plus so here 11 square is equal to 121 plus square of 60 is 3600. The sum is 3720. That means here 61 square is equal to 11 square plus 60 square. So this is also called a Pythagorean Pythagorean triplet. Now in last year we have studied the properties of right angle triangle with angles 30 degree, 60 degree, 90 degree and 45 degree, 45 degree and 90 degree. Now we will revise those properties in short. The first property is the property of 30 degree, 60 degree and 90 degree. Property of 30 degree, 60 degree, 90 degree triangle. Of course, this is the right angle triangle. Suppose LMN is a right angle triangle. Angle L is of 30 degree, N is of 60 degree, 90 degree. Triangle LMN. So in this triangle, if the angles are 30 degree, 60 degree, 90 degree, then the side opposite to 30 degree is half of the hypotenuse. Now see here, this is LM is the hypotenuse. Now angle MLN about 60 degree and side opposite to 30 degrees MN, side opposite to 60 degrees LM and side opposite to 90 degrees LN, that is hypotenuse. That means here according to this property the side opposite to 30 degree, that means MN, is half of the hypotenuse. Hypotenuse is LN, that means half of the hypotenuse. This is first property. And second is side opposite to 60 degree, that means LM, side opposite to 60 degrees root 3 upon 2 times the hypotenuse LN. These are the two properties we have studied in last year. For example, now here we will take the length. For example, here Ln, the length of the hypotenuse is equal to 6. So according to this property, then the side opposite to 30 degree is half of the hypotenuse. That means here according to this formula Ln is equal to 1 half into 6 equal to 3. And side opposite to 60 degree is root 3 upon 2 times of hypotenuse. That means according to this formula Lm is equal to root 3 upon 2 into 6. Hypotenuse is 6. That is equal to 3 root 3. So here we get this length half of hypotenuse, that means 3. And side opposite to 60 is 3 root 3. That means root 3 upon 2 times of hypotenuse. This is the first property, 30 degree, 60 degree and 90 degree. So now we will study second property, the property of 45 degree, 45 degree, 90 degree triangle. So this is also a right angle triangle. Now suppose this triangle XYZ. Triangle XYZ of 45 degree, 45 degree, 90 degree. That means here angle X is of 90 degree, angle Y is 45 degree, angle Z is 45 degree. So in this triangle, the property is if the acute angles of right angled triangle are 45 degree and 45 degree, then each of the perpendicular sides is 1 upon root 2 times the hypotenuse. Each of the perpendicular sides is 1 upon root 2 times the hypotenuse. That means here in this right angle triangle, angle ZXY is equal to 90. Now XY and XZ are perpendicular sides. Both the sides are congruent. So length of each side is equal to 1 upon root 2 times the hypotenuse. YZ is the hypotenuse. That means here XY is equal to XZ is equal to 1 upon root 2 into hypotenuse. That means, so length of each perpendicular side is equal to the 1 upon root 2 times of hypotenuse according to property. This is the second property. So suppose in this triangle, the length of hypotenuse YZ is 3 root 2. So according to the property, here XY is equal to XZ. XY is equal to XZ is equal to into hypotenuse, that is equal to YZ. So here 1 of root 2 into hypotenuse is 3 root 2. So root 2 gets cancelled here 3. So each side XY and XZ, each side is equal to 3.